contains one of the ions in your solid that you're going to dissolve. And then you'll see that silver chloride is less soluble in a solution that already has silver in it or already has chloride in it. Because you can see that you already have part of your solubility product there. So when I say that concentration of this times concentration of that gets up to Ksp, if there's already either one of these present in the solution, then the amount of this that I can add, the amount of silver chloride that I can add is going to be smaller. So I have Ksp is 1.8 to the negative 10th, and I want to know how much silver chloride will dissolve in 1 liter of 0.55 molar sodium chloride. So I'm going to write the equation like I always do. AgCl. It dissolves. It makes silver, and it makes chloride. Okay, so initially, the thing that I care about is this is 0.55 molar sodium chloride. It's the chloride. Sodium's not going to do anything. It's a spectator ion. So I have 0.55 molarity of the chloride. My question is, if I add some silver chloride and X of it dissolves, putting X amount of silver and X amount of chloride at equilibrium, how much will I have? So I have my K expression, and I know that 1.8 times 10 to the negative 10th equals the concentration of this times the concentration of that. So at equilibrium, it's that times that. So I have 1.8 times 10 to the negative 10th is equal to X times 0.55 plus X. So X times 0.55 plus X. This is my favorite part. We're going to make the math a lot easier. I know that since this is going to be 0.55 plus some amount times X is going to equal 1.8 to the negative 10th, I know X is going to be small. It's going to be close to something to the negative 10th. So 0.55 plus something to the negative 10th is basically 0.55, especially in chemistry. In chemistry, we're limited on how well we know numbers because we have to measure everything. So if we measured this molarity to be 0.55, actually we know this and we estimated this, we certainly don't know the thousandths or 10,000ths place or all the way down to the times 10 to the negative 10th place. We don't know that. So basically, I can say 0.55 plus something to the negative 10th is still 0.55. I get to do this. Ooh, good times. All right, so my math just got a lot easier. Now I just have to get the X alone, so I'll divide both sides by 0.55, and I'll end up finding out that X is equal to 3.3 times 10 to the negative 10th. Okay, and X was the amount of silver chloride that could dissolve. So it was saying how much silver chloride dissolves. This many moles per liter of silver chloride will dissolve in this solution. And what I want to do now, just to make sure that I'm right, I made the assumption that 0.55 plus X was equal to 0.55. First, let's check that out. Let's look at the X. So if I have 0.55 and I add to that this, so that is, all right, that's going to be small. Okay, so 0.55. Yeah, I'll say that's pretty much still 0.55. So the assumption looks pretty good. The other thing you should do is take this X and plug back in here, and see if this really is pretty close to that. And when I did that, it was really close. It was 1.815 times 10 to the negative 10th. So I'm going to say, yeah, that works. So that's how much silver chloride I can add to that. And you know what? What this shows is that since this chloride was present, a lot less sodium chloride dissolved. Because if I were just dissolving the silver chloride in water, dissolving the sodium chloride, it would be X times X. So it would be the square root of this guy would be equal to my Ksp. I could dissolve 1.3 to the negative 5th, which is significantly more than 3.3 to the negative 10th moles per liters of silver chloride. So by having chlorine here, the silver chloride became less soluble. It's called a common ion. And you saw that in equilibrium, when you add to this side, it shifts over to the other side. So that prevented the silver chloride from dissolving. So here's another one. I have a solution. It has chloride and chromate. I'm going to add some silver nitrate. This is soluble. Nitrates are always soluble. but the silver is insoluble with the chloride because it's a halide, and it's insoluble with chromate. Chromate's typically insoluble. So I'm going to make a precipitate, and I'd like to know which one I'm forming, partly because chromate's bad. So I'd like to know what precipitate it is that I'm forming. So what I'm going to do is I'm going to see how much silver nitrate can I add before I start making a precipitate of silver chloride or of silver chromate. I'm going to treat them separately. So first let's make some silver chloride. So I know it makes silver, it makes chloride. Oops, that's a 1 minus, by the way. And let's see, it's 0.01 molar here. And I'm adding the silver nitrate until I get this concentration up to some amount that's going to start to make the precipitate. So when it starts making the precipitate, that's when the product of these solubilities, or the product of these concentrations, is equal to Ksp. So that's 1.8. 1.8 times 10 to the negative 10th is going to be equal to x times 0.01. So I just have to solve for x. I'm going to divide both sides by 0.01, and x is equal to 1.8 times 10 to the negative 8th. So that's how much silver nitrate I have to add to make a precipitate of silver chloride. Let's do the same thing for the silver chromate. So for that one, it's Cr04. That's my silver chromate. It's going to make 2 silvers and 1 chromate. Okay, oops. That's 2. Okay, and I'm starting off with 0.01 here. I'm adding some amount of silver because I'm adding the silver nitrate until the silver chromate precipitates. I don't need to add anything to the chromate because by adding silver nitrate, I'm not adding chromate. So I know that when I plug these into the K expression, it'll start to precipitate when the product of these guys is equal to Ksp. And so Ksp for silver chromate is 9.0 times 10 to the negative 12th. Okay, and that is equal to x squared, because it's concentration of silver raised to its coefficient. So x squared times concentration of this guy, 0.01. All right, so I'm going to divide both sides by 0.01, and I get that x squared is equal to 9.0 times 10 to the negative 5th, or 10th. And then I'm going to square root both sides. So square root this, 3 times 3 is 9. To the negative 5th times negative 5th, it's going to give us to the negative 10th. So that's 3 to the negative 5th is equal to x. All right, so that's how much silver nitrate I need to add to start precipitating the silver chromate. So between the two, this is a lot smaller, right? Because I'm looking at 0.00 versus, yeah, this is small. Okay, so this one's going to start precipitating first. So as soon as I've added that much silver nitrate, I start precipitating silver chloride. Silver chloride precipitates first. Okay, then the question is, how much chloride is going to remain when I start precipitating the chromate? That's what the whole question was. So when I start to precipitate the silver chromate, I know the concentration of the silver is going to be 3 to the negative 5th. And the question is, when I start precipitating that silver chromate, how much of the silver chloride, or how much chloride is left? So I'm looking again at this equation, silver chloride, and I'm saying, when I start to precipitate the silver chromate, how much chloride is left? Well, that starts happening when silver is going to be at 3.0 times 10 to the negative 5th. That was the concentration of silver when the chromate started to precipitate. And the question is, how much chloride is going to be left at that point? So I know that anything beyond their Ksp amount is going to precipitate. So Ksp was at 1.8 times 10 to the negative 10th. It's equal to these guys at their, being saturated, 3.0 times 10 to the negative 5th, times how much chloride could be left. Okay, so I will divide both sides by 3.0 to the negative 5th, and I'll find out that x is equal to 6.0 times 10 to the negative, let's see, that's going to be negative 6. Okay, so that is, that's my x. The x is the concentration of chlorine. So So what that means is when I've added this much silver, I start to precipitate the silver chromate, and this is the amount of chloride that would be left by the time that I start precipitating my silver chromate. And